So there's three main things I wanted to cover in the next 35, 40 minutes or so. One, you can offer kind of the big picture of what are the major factors that affect the quality of our stream resources in the Driftless area and elsewhere. And then I'll get into the focus of my talk as far as issue with Neonicotinoid Insecticides. I'll use the term Neonics instead. It rolls off one's tongue a little easier. And then, as Sarah mentioned, I'll share some findings from our 2022 sampling in the state of Wisconsin. So Seth Meek was a naturalist. He spent most of his life in Iowa, but occasionally in his wanderings through the natural world, made some visits to northwestern Illinois and southwestern Wisconsin. The reason I'm sharing this quote by Seth Meek is that you can see here, well over 100 years ago, people are starting to make the link between human population growth and changes in land use and how it affects our aquatic resources. And it's sad to say it's a lesson that each subsequent generation seems to have to relearn. So I'm going to, again, offer kind of a big picture. What are the major factors or determinants of stream health? I'm using this fancy term, stream integrity. So think of that as, again, stream health. So there's 5 major factors that affect streams. You can read them here: flow regime, water quality, food chain, stream continuity, and habitat. Now, so this is a conceptual model. It's been said that models are lies that help us see the truth. So this is a little lie I'm going to share with you folks in the next 10, 15 minutes or so. So first off, flow regime, the quantity of water in a stream and how it changes over time. So we all know that the upper Midwest is getting wetter, and you can see here in this graphic, infographic, that also seeing an increase in storm frequency and storm intensity. So what does that mean for the trout streams of the Driftless area?
Hey, Mike, we're getting some audio suggestions. Can you get the mic a little bit closer to you?
Sure. Is this any better?
Slightly.
Will help if I speak up.
Possibly, yes. Thank you.
Okay. All right. So what we're seeing in this photograph is the edge of a cornfield after a rainstorm event. You can see not only was water moving off the site, but tons and tons of topsoil as well. So we got this issue of increased rainfall, but also we have unprecedented increases in the amount of groundwater that we're pumping for various reasons. You can look at this map here and look at the legend. You can see, well, one note that the blue dots on that map show where there's municipal wells. The larger the dot size, the greater the pumping. So the largest dots indicate wells that can pump over 1,000 gallons per minute. The green dots represent agricultural irrigation water uses. So we're pumping lots of water. I'm going to go through a 50-year time series of how we're increasing the number of high capacity wells in the state of Wisconsin. So how does that look like on the landscape? So here we have this Cook Creek. It's in the center of the Driftless area, west central Wisconsin. What you can see in this photograph off to the right, roughly about 400 yards away, is a gravel quarry. And right now the high cap well for that quarry is pumped. It's turned off, the pump's turned off. Now I'll share an image where the pump's been turned on. So Cook Creek is frankly, it's a nice little brook trout stream when there's water in it. Since these photographs were taken, the Wisconsin Department of Natural Resources has worked with the quarry operator about pumping groundwater in a more intelligent fashion. So moving on, the issues of water quality. So this is not your average sized dump truck, but the trucks you see out on the highway, they can hold roughly about 15 tons of soil. So based on a study done by the U.S. Geological Survey in the state of Wisconsin, they've estimated that in a relatively small watershed, again, roughly 100 square mile watershed, we're losing upwards of about 40 tons of topsoil per day, 40 tons per day. So then that equates to roughly about 2.5 dump trucks soil moving out of that watershed each day. That, of course, can have a number of impacts on water quality, and I've listed a few here. Issues of water turbidity or transparency, phosphorus, a nutrient in our surface waters is particularly associated. So when soil particles move into the water off the landscape, they bring phosphorus with it. Also, there's the issue of scour, where the particulates suspended in the water can scour the aquatic macrophytes and paraphytic growth on the rocks. It's important food for invertebrates and frankly scour the invertebrates themselves. And lastly, a very significant impact is sedimentation of the stream bed. There's studies done by the US EPA's National Rivers and Stream Assessment suggests that upwards of 40% of the streams in the entire United States have excess stream bed sediment. So that really has a real profound negative effect on the quality of our aquatic resources. So I'm not a big sports fan, but here's a photograph of Camp Randall Stadium in Madison, Wisconsin, the home of the Badgers. You can look at the information there up above, where we have over 1.2 million dairy cows in the state of Wisconsin. And if you look at that equation, note that on average, one dairy cow produces 125 pounds of manure a day. One cow, 125 pounds of manure a day. And if you do that simple computation, we estimate just the dairy cows in the state produce 54 billion pounds of manure each year. Now, again, I'm just talking about dairy cows here, so I'm not talking about beef cattle, chickens, hogs, sheep, goats, horses, turkeys, ducks, whatever. Just the dairy cows in the state of Wisconsin produce enough manure every 4 months to fill Camp Randall Stadium. So for those of you that might be Badger fans, next time you're at a Badger game and things are a little bit slow, you can reflect on that fun fact. And again, based on national studies done by the US EPA's National Rivers and Streams Assessment, the EPA estimates that over 50% of the streams in the United States have excess amounts of phosphorus. So if we're not smart in how we manage that manure production by the livestock, we end up having eutrophication problems in all our surface waters, not just streams. So moving on to this issue of stream continuity. Are the streams connected or not? Or are they fragmented by various practices on the landscape? So this brook trout desperately wants to move upstream to spawn, seeking out some natal spawning habitats. But unfortunately, because of the poor engineering of this road crossing, the culvert was set too high on the landscape. So what we end up with in this incident is both a behavioral and physical barrier, and the water is too shallow for the fish to effectively move upstream through that pipe to get upstream. And also this issue of many fish species and other animals for that matter. Of course, when they're exposed to potentially exposed predators, they're going to be reluctant to move forward. So that's what's happening here. That fish wants to move upstream and spawn, stalled out because of the stream fragmentation occurring here because of this culvert. It's not just an issue with fish. Again, a lot of our amphibious species and mammal species as well rely on these stream corridors as movement pathways. And a sad day for Mrs. Wood turtle. This particular turtle has to run this gauntlet at least twice a year, going from upland summer habitats to lowland overwintering habitats. And it needs to do this at a minimum of 35 times before it can become sexually mature. So unfortunately, this turtle didn't make it in this instance. So again, it's not just an issue with fish, but many other animals as well. And again, as our wild lands in the country become reduced in size and become more fragmented, these riparian corridors, the streams themselves and the habitat along the streams are fundamentally important pathways for wildlife. So we need to make certain that we don't disrupt those pathways. So just to kind of drive home that point. So how does this fragmentation come apart or come about? So in Wisconsin, we have well over 100,000 roadway miles in this state. And if you include both the ephemeral and intermittent streams and the perennial streams, I think we have somewhere around 84,000 miles of streams in the state of Wisconsin. If you overlay using GIS, for example, you can take a roadway layer and overlay that on top of a stream layer, a hydrographic layer, come up with this estimate of roughly about 80,000 road stream intersects in the state of Wisconsin. And frankly, this is a fairly low ball estimate. This does not include private driveways or forestry logging roads or agricultural machinery crossings of streams. So at a minimum, we have 80,000 crossings. likely many more. So we did a study roughly about 10 years ago where we selected a random sample of 100 different stream crosses in the entire Driftless area, so all 4 states. And then we had crews go out and collect data on each one of these sites, measuring flow velocity and water depth, and whether or not there was a perch culvert creating a waterfall in the downstream end, whether or not there's plunge pools, which are evidence of high velocity flows during certain times of the year. So a number of different visual estimates are made along with some physical measurements as well. And this is what we came up with as far as our estimates of the number of barriers to fish passage, upstream passage in the Driftless area ecoregion. So again, significant proportion or complete barriers, many of those were, again, these perch culverts creating miniature waterfalls, or sometimes bridges have concrete aprons underneath them that also create these miniature waterfalls. And we also had estimates of partial barriers. We defined those as those culverts, for example, water depth was too shallow to pass certain sizes of fish, or the water velocity was too great that some fish species that are either smaller and just weaker swimmers have a difficult time passing up through the pipe going upstream. And also we had evidence of a number of sites where high flow barriers were, particularly in the springtime when there's runoff event, the water velocity, the culverts are too high to allow for fish passage. Again, but those tend to be fairly temporary in nature, typically in the springtime or during runoff or storm events. And lastly, again, some of them were not barriers at all. Moving on to habitat, to be fairly self-explanatory, but well, I'll throw out a term for the non-ecologists in the room. So this term we use called ecotones. Anytime 2 distinctly different environments butt up against one another, that's an ecotone. So you can think of forest and a prairie, we have this edge effect, or the same thing occurs with streams. We're looking at Elk Creek here. Again, if you counted, weighed, estimate of biomass of all the animals that lived in Elk Creek, and then compare that to the uplands, you can measure what animals lived in the upland areas. And if you did the same thing at that land-water interface, what we typically find is it's a much richer environment. There's more animal biomass, more species diversity at that land-water interface. So if we're concerned about the health of our streams, we need to protect those riparian corridors. But also it's fundamentally important for these edge species and upland species as well. So we need to protect the stream riparian corridors if we want for healthy and functioning uplands and stream resources. Moving on to the food web. So I touched on briefly this issue of that we have excess sedimentation in our streams, and what that often does is it really fills a really critically important habitat. I'm using the term interstitial habitat, where we have coarse substrate like rocks and boulders and cobble, that sort of thing. And that gets filled in with sand. We lose these spaces among the rocks. So it's fundamentally important habitat for invertebrates and fish species and other animals as well. So we got an image of a mayfly here. There, mayflies and many other aquatic insects are kind of the cows or streams that graze the stream bed, whether it's plants or rocks or whatever. And so nearly every surface on a stream bed that receives sunlight has this paraphytic growth. It's a mix of algae and bacteria and fungi. And that's a very rich food source for many invertebrates. So when we see excess amounts of phosphorus in our streams, you see a shift in the food chain, one that's less desirable, that has a higher composition of filamentous algae as an example. So again, it becomes a poorer food source for many of the grazers that inhabit our streams. Just kind of to give a parting thought on the importance of invertebrate biomass. And Edward Wilson was a Harvard ecologist. He passed away about 2 years ago. He was the world authority on ants. And for those not familiar, this animal in picture, this net-spitting caddisfly, it lives on the stream bed during its immature stages, and it spins a web. They're close relatives to moths, as an example. They spin a silken web to filter food out of the water. So if we lose these caddisflies, that has significant impacts on the food chain. In many of our driftless area streams, these caddisflies make up roughly 30% of the invertebrate biomass living on the stream bed. So if we lose that third of the biomass, again, say goodbye to 30% of the fish biomass, 30% of the northern water snake biomass, 30% of the blue heron biomass, the list goes on. These caddisfly larvae are drab little fellows. They're about a half an inch long. They got a Latin name about 2 inches long. So who cares about these crummy little caddisflies? Well, they're the base of the food web. If we lose these animals, it can have profound effects. Time checked in for me. So moving on to what I came here to talk about, this issue of the risk that neonicotinoid insecticides pose to our streams. My alternative title for my presentation at this point is "Where Have All the Insects Gone?" And there's some recent reports, proceedings by the National Academy of Sciences and also the Entomological Society of America, who have put out some fairly recent reports indicating that we're seeing significant decreases in invertebrate species richness and biomass, both terrestrial and aquatic species. And they also conclude that, one, we don't have very good data to look at trends, and it's very challenging to measure these types of estimates. But the point is, and I think many of you on this call, based on your own experience of fishing some of your favorite waters over many decades, have noticed declines in some of your favorite emergencies of mayflies, perhaps, or caddisflies. So there's lots of anecdotal evidence and increasing amount of empirical evidence as well. So I'll kind of scroll through quickly what I want to talk about in the world of neonics, talk about what they are, how they're used, and the risks they pose. And some of this is redundant from my presentation last year. Hopefully it's worth revisiting. So again, the idea that these compounds are synthetic derivative or versions of compounds produced by certain plants that ward off insect pests. And what we see here in these pictures, the underside of a soybean leaf or aphids, which are a sucker feeder. They draw the sap out of plants. And so, and these plants produce neonicotinoids to ward off these pests. It should be recognized that these chemicals, these neonics, are neurotoxins. And there's some key points here I want to bring to your attention. One, these chemicals bind permanently to these neuroreceptors. So the point is, if you're for example, say a beaded mayfly that lives in a stream for maybe 3 months, you're going to get a certain amount of exposure. Contrast that, for example, with a hexageniidae mayfly that might live as a larval specimen for upwards of 2-3 years on the stream or river bottom. They're going to get a much different exposure than that beaded mayfly. So again, the time spent in the water column can have significant impacts on whether there's a toxic effect or not. Also recognize that there's a number of different neonicotinoids that are commercially sold in the United States. They all have the same action as being neurotoxins. So we look at data from our sampling efforts. We need to recognize that there's an additive effect. And also these chemicals are described as being safe for, that's true for, to some extent, with vertebrates, but it's really not wholly true for invertebrates. And just give you a feel for how these compounds are used across the landscape. By and large, the majority of these chemicals are used as seed dressing. So prior to planting corn or soybean or other grain crops, chemicals are applied to the seeds prior to planting. Again, it's very difficult, if not nearly impossible, for ag producers to be able to buy seeds that are not coated. That holds true for corn and to a large extent for soybeans. So even if the farmers don't want to use these chemicals, they're almost obligated to do so. And unfortunately, this kind of pre-treatment has led to a number of changes on how ag producers manage their croplands. Instead of rotating crops, they have continuous corn or soybean, which allows pests to build up, and they no longer monitor for pests and treat them necessary, but apply these chemicals prophylactically, for better or worse. A quick time series on the use of these chemicals in the United States, going from 1995 to the present, or actually 2015. I'll stop at. And just imidacloprid is just one of 5 major neonics used in the United States. So, flavor for the increase in usage across the landscape of the United States. Since 2015, federal government stopped tracking the use of these chemicals. I don't necessarily understand the details on that. But the point is, since 2015, we only have good trend data for the usage across the United States. So other physical properties of neonics you should be aware of. They're water soluble, so they mobilize the environment quite rapidly. They're relatively long-lived depending on the environmental conditions and compounds themselves. And lastly, to me, it's kind of startling that, again, these seed-applied chemicals, the vast majority will wash up off the seeds before even taken up by the plants. So what are the risks of these chemicals? Again, some of you have not heard of neonics before, but I suspect nearly all of you have heard of colony collapse in honeybees. And again, these compounds are extremely toxic to vertebrates. So the example here of LD50 of 5 nanograms per individual bee. So what that means is in a test population, dose of 5 nanograms, so that's 5 billionths bee nanograms of neonics, enough to kill half the test specimens in the study, test organisms. Again, these chemicals are thought to be about 10,000 times more toxic than DDT. A little analogy here where, again, 1 sugar granule worth of neonic is enough to kill 125,000 honeybees. And to continue with that analogy, the sugar packets that you pour into your coffee or tea or whatever, they hold roughly about 3 or 4 grams of sugar. Comparable amount of neonics is enough to kill 600 million honeybees. Again, we're not tracking these chemicals very closely, so we have some crude estimates of the number of tons applied in the United States. Again, don't have a solid accounting. So what are the benefits to the ag producers? So this study by Grote and others from Cornell University, they looked at 331 different field trials. Field plots, test plots that had neonic applied, chemicals applied to the seeds, and ones that had no chemicals applied to the seeds. You can see here that the vast majority of the test studies showed that there was no benefit to the ag producer when they applied neonics to their corn seed prior to planting. So again, 15 different states, data from 15 different states and 2 provinces. Same story holds true for soybeans, where in the proportion of test trials where the benefits of neonics were demonstrated was about 18%. Recognize these increases in crop yields were fairly negligible. Like in some cases, the increased benefit of producing more corn or soybeans in this example didn't offset the cost of the chemicals themselves. So quickly, just why is that happening? These chemicals, if you look at this illustration here, look at the pink or salmon colored wedge, that represents the concentration of neonics on the seeds. You can see it tapers off as we progress into the springtime. And if you look at that purple, bluish, bell-shaped curve, that represents the increase in the population of aphids on the plants over the course of the growing season. So the point being is that most of these chemicals have washed off the seeds and flushed out of the plants themselves by the time the aphids populations are increasing. Another interesting fact is that when we apply these chemicals in crop fields, we often kill the natural predators of aphids and other pest species, resulting in pest outbreaks. So some findings from Wisconsin. I have 5 minutes left, so I'm going to breeze through this pretty quickly. So what we did last year was we identified 100 different random sites across the landscape, wadeable streams. We stratified by different land use types of each one of the watersheds. You can see here the gray dots are for urban areas. You can think of where they apply granular neonics to turf, green space, or athletic field. We have vegetable crops, so things like potatoes and carrots and snap peas. Then we have population of streams where this from watersheds draining primarily soybean and cornfields. And then this idea of the undefined, where it's just random sites across the landscape, irrespective of any type of watershed land use. Again, within these different strata of populations, we selected random samples of sites across the state. And then I submitted samples to two different labs. One, Wayne State University, analyzed samples for 5 different neonics, and the other at another lab, an EPA lab, they analyzed splits of these water samples. They looked at 300 different pesticide compounds in those water samples. I haven't worked up any of the 300 compound data set yet, so I'm just going to share Neonic findings with you this morning. So this is what's called the box and whisker plot. And I apologize for those that are not familiar with these. Again, I'm just talking about the urban sites that we sampled. So box and whisker. Here's the box. Here are the whiskers. That whisker's kind of compressed. But the point is, this bottom whisker shows the minimum concentration found. This to here shows the 25th percentile of where, again, 25% of the samples had a concentration of 2 parts per trillion. And the box represents 50% of the data. This X represents the average concentration found in this population of the streams. This white line represents the median value. So half the samples had concentrations below this level and half had above this level. But the point is, in this study by Morrissey et al., they concluded that roughly about at 35 parts per trillion, we start seeing chronic toxicity in aquatic invertebrates. So the point is, on average, there's a chronic concentration of neonics in our urban streams are at a chronic toxicity level. Many are higher than that. Now moving on, and that's why this box plot was kind of compressed, because the difference between urban sites and now these vegetable water dominated watersheds. So we see a much higher concentration of neonics in these watersheds where vegetable crops are being grown. And so you can see here that all the concentrations found in that sample population were above this chronic toxicity level. And many, actually the average concentration, noted by the X, shows that concentrations found in these sample population streams are an average above the acute toxicity level for aquatic invertebrates. And then we add to that watersheds where we sampled watersheds that had corn and soybean production, so you can get some understanding of roughly about 30 or 40% of those sample sites had chronic toxicities of neonics, and there are some higher outliers as well. And lastly, that statewide random population, you can see here that for the most part, on a statewide basis, at most of the sites we sampled, toxicity or the concentrations were below chronic toxicity level. I apologize for kind of rushing through that. Some other findings. Can the Wayne State Lab analyzed for 5 different common neonic compounds in the water samples, and 3 that are used primarily for corn and soybean are quite prominent. But note that 85% of the samples had detectable concentrations of neonic. So of those 100 randomly selected sites, 85 of them had neonic detected in the water. And if you plug in this toxicity data, you can get some estimates of potential impacts on our aquatic resources. Another study done by Bartlett showed that mayflies will oftentimes vacate their burrows at relatively low concentrations of neonics, starting at roughly about 10 parts per trillion. So again, we might be seeing behavioral effects about 17% of our streams, and based on the chronic toxicity levels, it's between 35 and 200 parts per trillion. You see that upwards of 28% of the streams had concentrations that one could suspect chronic toxicity. And then based on the study, and at higher concentrations over 200 parts per trillion, roughly 10% of the streams had toxic levels, acutely toxic levels of neonics. So suggests that we're having significant impacts on our aquatic invertebrate streams in Wisconsin. We did some sample sites, do some trend analysis over time. So running out of time, I'll kind of buzz through this. So just quickly, the take-home message here for this trend sampling was that the gray bars show base flow concentrations of neonics, and at those same sites, we collected an event flow when there's a rainstorm event. So the take-home message here is, I guess I listed them, that 1, neonics are detected in all these sites when we did the trend analyses. The neonic concentrations increased as we went from upstream to downstream, and then also that there's a significant increase in neonics after rain events. So back to the sampling I did, if it was during base flow conditions, we may not see the true concentration of neonics that are showing up in the streams. One last image. So again, this Wayne State University lab analyzed primarily for these neonics and showed up quite frequently. Again, just based on some very preliminary analysis of the EPA data. All these chemicals shown here were showing up in greater than 50% of 25 samples that I submitted to the lab. So again, each water sample, each stream had those different compounds in addition to neonics. So I need to delve into this data in the next few months. So with that, very quickly, again, neonics are used prophylactically, regardless of if there's an insect outbreak or not, or pest outbreak. Again, the benefit to producers is somewhat dubious. Again, they accumulate in soil and move in the water. Lastly, we're finding, based on this particular study anyway, that we're seeing chronic and acute concentrations of neonics in our streams. I apologize for going a little bit long. Turn it over to Sarah.
Thanks, Mike. You're actually okay on time.
Good.
I would like to open it up for questions. Folks can submit those in the Q&A section. There was one submitted already from Dave asking if you could try to discuss the impact of these compounds on the Driftless area. I know you have only limited data worked up at this point for the Driftless, but
Sure.
you care to expound?
Sure. Quickly, and I'm remiss for not kind of subsetting out that data from the Driftless area, but I'll have better information in another month or so. I can take those random sites from the Driftless and make certain that they are data from cold water streams, that sort of thing. So I can be much more exacting as far as the impacts to the Driftless area. It's chemicals. At this point, I just give you a shotgun perspective of the state of Wisconsin.
Thanks. And that actually is a good segue to a question John Weiss raised about extrapolating to other states based on what you've looked at from the literature and the NSRA sampling. Do you think it's a similar trend?
Right.
In other states?
Yep. Yeah. And frankly, I think the state of Minnesota, for example, I think they have an excellent pesticide monitoring program for streams. So the data is there. And again, concentrations data is there. All you need to do is relate it back to some of these toxicity studies. I feel to mention that toxicity study I talked about the Morrissey paper. What they had done was they took data from 23 different studies, toxicity to aquatic invertebrates, and came up with these thresholds of chronic and acute toxicity. So you think a fairly straightforward process to relate those concentration data for Minnesota or any other state that's such sampling data and see what kind of impacts are occurring on the landscape.
Yeah, and Mike, that actually, I wanted to touch on that just a second because I wasn't sure if you covered the difference between chronic levels and acute.
Right.
That might be helpful.
Yeah, sorry, I brought that up. So chronic toxicity, again, most of these lab tests are short-term exposures of maybe 48 hours, 96 hours at most. So when they're seeing impacts organisms, whether it's death, reduced movement, or other endpoints, I'm not certain all of them, but so that's kind of a chronic effect versus an acute effect would be death within that time frame of that particular study. So I apologize for glossing over that.
Oh, no worries. We have, let's see, we have several questions that have come in. I think we actually have time to take a few. We had a question asking how we might discourage the use of neonics. Might be a little out of your normal ballpark, but.
Well, yeah, I mean, one, it's educating you folks and then you educating others that are involved in these issues. And then frankly, this is a legislative issue. So we just need to kind of raise our level of concern to educate ourselves and share that information with legislators that have the rulemaking authority for whether or not we can use these chemicals. So we got to speak up. If we don't do it, I'm not certain who is.
Very good point. I have another question asking about groundwater and whether anyone is measuring these compounds showing up in groundwater?
Right, right. And then, yeah, Wisconsin's Department of Ag, DATCAP, Department of Ag, Trade, Consumer Protection, they have a very robust monitoring program. Like, what I recall is that we're seeing some detects between shallow wells, but not in some of our deeper wells where aquifers we tap into. The wells might go down like 300 feet or something. So I think for the most part, what I recall is our groundwater is fairly safe. Now that may not hold if you have a rural well where you got a sand point that's driven into 100 feet of soil or something. So again, the data's out there. It's just a matter of compiling that good mission. We need to compile the surface and groundwater data to a more comprehensive assessment.
Excellent. I had another question related to the sampling window for the actual field data that you collected. Was that when did that occur throughout the planting and growing seasons?
Sure. So I had one round of sampling starting kind of pre-planting, and then it's primarily through the cropping season into the fall. What I see in the literature is we see a spike in these chemicals start moving out the seeds about a month after planting. So you'll see a spike in maybe June, and then for whatever reason that's not known, you see another increase in concentration sometime in the fall. And I did one round of winter sampling. We're finding these chemicals in the water year round. So again, it certainly peaks out during their use in the summertime. Again, they don't disappear in the wintertime, sad to say.
Right, right. This crosses over to some work that you've been doing on macroinvertebrates. I have a question asking whether or not you've been able to compare macroinvertebrate diversity before and after widespread neonic use.
Yeah, we've been data mining. We go like a mere 2.8 million specimens and 12,000 samples, and it's very messy. The sampling wasn't done over the years to look at trends. We changed that recently, about the last 20 years, but it doesn't predate the Neonic. So frankly, I've been pulling my hair out trying to make heads or tails of the data, but I have a couple of bright people that are good big data scientists that are helping me out. So I'd like to think we can shed a little more light on the question in the not too distant future.
Excellent. I think maybe I have time for one more question here, and then we'll try to get our next speaker queued up. Someone asked if you feel there's enough research covering the impacts of these chemicals on stream biology and the cumulative impacts of all the different chemical formulations out there and physical stressors to get a sense for the overall health incorporating this chemical side that's sort of newly emerging.
Yeah, it's sad to say, my opinion is we're not even close. So, we're just starting to look at some of these chemicals, a long laundry list of chemicals I show you from the EPA lab. I can maybe pronounce a third of them, much less have an understanding of what they mean. There's some good tools out there to start kind of teasing apart which chemicals are most problematic. I think from a first principles perspective, insecticides are going to be worse. Fungicides, they may impact the gut fauna of us and our invertebrate friends, and then the herbicides, no doubt, they're affecting some of the algae and macrophytes in the streams. But so anyways, we have some crude understandings of which chemicals we probably should pay closest attention to, trying to relate these chemical stresses versus sedimentation versus storm intensities. It's a pretty challenging effort.
Absolutely. Well, and I guess I'll jump in with one more. A question was raised about research on fungicides. This whole class of neonics is primarily, insect focused. Have you even started looking in the realm of agricultural fungicides?
I personally have not. I'd like to think people have. I had heard comments of some people talking about fungicides impacting gut flora that helps transmit food from our gut to our bodies, and so there's some thoughts that fungicides may be affecting that. It's extent of my knowledge.
Great. Well, Mike, again, really appreciate you joining us today and giving this background on a really, critical issue, and one that I think has had a lot of interest given how many views of your prior presentation were out there, and how many questions I see moving around through the cold water stream community. So very much appreciate your time and the research that you're doing.
I really appreciate the opportunity, and thanks for everyone's interest.